Sorry, before we start. I'm Jabusi Tole for technical science. Today's lessons will be forces and Newton's laws of motion. Now, it is very important that as we are dealing with grade 12, you must know the topics covered in paper 1. Paper 1 covers mechanics, it covers electricity and magnetism, it covers waves and sound and light. And there are marks that are very important allocated to this content. Mechanics, it has 93 marks, and electricity and magnetism contains 33 marks. Wave, sound, and lights contains 24 marks. So these are marks that you should know, and these are marks that you should grasp in the final year examination. Now, as we are dealing with mechanics, because the topic that we are dealing with, the forces and Newton laws, falls under mechanics. So you can see that mechanics has a lot of marks because there are many topics that are there. There are many topics that are there, and mechanics, it's contained 93 marks. So it is very important. Now, in terms of weighting, if we go for weighting, we've got 62% in mechanics. We've got 22% for electricity and magnetism. And we've got 16 for wave, sound, and light. But those two content topics we'll be dealing with later on. But today we will start with mechanics. And under mechanics, I said we'll be doing forces, Newton's law of motions. Now, exam guideline. It is very important that all learners have this structure of the exam guideline. It is very important because it's going to carry you through as we begin the year until you write your final examination. So it is very important that the educators and your teachers will give you this structure of exam guideline. For this is paper 1. There is paper 2 thereof that is containing the same format of the content that you will be examined when going forward in paper 2. So this is paper 1. So this is what you need to know in paper 1, learners, and this is how marks. Now remember, paper 1, the total marks of paper 1 is 150 marks. So in other words, 93 marks contributes to the 150 marks of the whole paper at the end of the year. Even in your preparatory exam, you will have the same structure, and then it will be 150. So, and your duration of the duration of the paper for paper 1 is 3 hours. That is the duration. In other words, you'll be sitting for the examination, you'll be sitting for 3 hours writing for 150 marks. So it is very imperative and is very important that you understand that as we are dealing with mechanics, because as we start the year, we will be dealing with mechanics. And under mechanics, you'll be dealing with the first chapter with Newton laws of motion. So the weighting in terms of a question or cognitives, we'll deal with that later. But what is very important for now, it is you know what is the structure and how the structure of the content be in terms of this exam guideline. This exam guideline was instituted last year, 2021, so it's still working in 2022, so we'll be following this exam guideline. So it's very important that you know the exam guideline. And I will appreciate if you take this exam guideline, you paste it in your book. It's very important. paste it in your book so that you follow and you know what is happening. We are going through now the Newton's law. Basically, what we are going to learn in Newton's law is that we have three laws that we need to familiarize ourselves with this. We have Newton's first law, Newton's second law, and Newton's third law. These are the laws that you need to know. And these laws, as I'm going to explain, this is a summary. I'll go through it one by one as we are moving along. But this is a framework that you need to know. It's going to tell you what is happening as we are moving forward. Now, I said Newton's first law, as you look at this summary, Newton's first law, it has inertia and the mass. In other words, it concerns itself with the inertia, the law of inertia and the mass. So hence this law is called inertia law. It's Newton's first law or it's inertia law. We'll define what is inertia, we'll define what is a mass and how these two have impact in Newton's first law. Now we have Newton's second law. Remember, Newton's first law, it's a constant moving object. We are going to talk about constant moving object or a zero moving object. But now if we go to Newton's second law, this is a non-zero force object. Now Newton's second law, it has the free body and the force diagram. These are the diagram that we are going to be required to draw as we go with Newton's second law. Remember, it will be having calculations as well. Now, how do you calculate? You will be using this formula, which is F net equals to MA. That is the formula that we'll be using to calculate the Newton second law. Then this Newton second law, it complies or it informs itself with what? Acceleration, because that is the movement of the subject. That's hence I said it's a non-zero force. It's where we apply a force and the object accelerate. Now we'll define it or we'll state the law. Now Newton's third law, it is the law that concerns itself with action-reaction pairs. In other words, we are going to talk about two objects which they oppose one another but having the same magnitude but moving in an opposite direction. So that will be pair reaction pairs. Then we'll define what is this law. We will define it. Then as I said, this is the law that we will be defining. All three laws, they need to be stated. All three laws, you must know how you state it. Now, I must say to you, the law, you will be required to state the law. Then if they say state the law, is going to be 2 marks or 0. It's either you get 2 marks or you get 0. So you must know how to state these three laws. So we'll go through how to state the laws and how the laws are going to be easily remembered when you state them. Now, we go through Newton's laws of motion. As we go, this is what we learned last year in grade 10, particular this. We learned it in grade 10 and grade 11. Now, a particular in grade 11. Grade 11, we spoke about the types of forces and the kinds of forces. We've got two types of forces, which is the contact force and the non-contact force. Those are two types. If we talk about the types, we talk about the contact and the non-contact forces. But if we talk about the kinds of forces, we talk about these. These are the kinds of forces. under the types of forces. Now, under non-contact forces, we've got 3 kinds of forces, which is friction force, normal force, tension force. These are kinds of forces. Well, I'm going to define it as we move along. But now I'm giving you a scanty summary so that we know what is it as I'm going through. You'll know exactly what is that I'm talking about. So in a contact force, which is a type, we've got 3 kinds of forces. We've got what? The friction force, normal force, tension force. Those are the 3 kinds of force. Now, in a non-contact force, we've got, there can be more, but I've only cited 2, which is the force of gravity or gravitational force, or you can say weight, and we've got electrostatic force. Those are non-contact force. Now we'll define what is contact force, what is non-contact force. But I was giving the scanty framework so that you familiarize yourself as we want going through the lesson. You'll know exactly what is it that I was talking about and what is it that we are saying if we're talking about the types and the kinds. They are different. You must know. They can say, name 2 types of forces. You cannot mention the kinds if they say types. So in other words, you will be saying contact force and a non-contact force. Those are the types. But if they say give types of forces, then you start to say friction force, you say normal force, you say tension force. Now on the non-contact force, you'll be saying force of gravity, or we call it a weight because it's a force that is pulling downward, and then the electrostatic force. Those are the forces that you need to know. And these types, kind of forces, they will help us when we are required to draw the force diagram. These are going to work here in a force diagram. Especially, there are 4 forces that they are going to work. 3 in a contact force and 1 in a non-contact force. Therefore, if you draw a free body diagram or a force diagram, you'll be using the frictional force, you'll be using a normal force, you'll be using what? A tension force. And you'll be using what? The weight, which is the force of gravity. Those are the forces that you'll use when you draw the free body diagram or you draw the force diagram, because we'll explain what is the free body diagram and what is the force diagram. That is very important. So as I'm explaining this, it's going to be very simple for you. Then while I'm going through, I hope and I believe that you have understood what I've said so far, and you know what is it that we are going to encounter as we are moving on. Now, I want to challenge you to say, I want you to take this framework and put it in your first page in your book and familiarize yourself with this framework, because it's very important that you know the framework. This framework, it says everything about Newton's laws of motion. We haven't yet started defining or stating the laws. We are only just unpacking what is it. I hope and I believe that you understand what we are trying to get ourselves in. Now, let the train begins and let us fasten our seat belt. We're already now on the train. Let us move now. In grade 10, let us remind ourselves with the grade 10 work and grade 11 work. Now, in grade 10, we made to understand that we need to define the force. We define the force as a pull or push, action exerted on an object. That's the definition of a force that we know from grade 10. That if you pull or a push on an object, then you are applying what? A force. That is, you are exerting what? An action on the object. That is a force. Now, we're told that force is a vector quantity. What is a vector quantity? It's a physical quantity that has both magnitude and a direction. That is a vector quantity. That is how we define a vector quantity. In other words, a force must have what? A magnitude, a size. It's 20 Newton. that is size, and it must have a direction. What the direction? Easterly direction. That is the size and the magnitude. Oh, sorry, the magnitude and what? The direction. So it must contain the two. Now, vector is measured in what? In Newton. Remember, we're talking about the Newton's law. So vector is measured in what? In Newton. So this is what we know from grade 10. This is what we familiarize ourselves with grade 10 work. But now, when we go to grade 11, remember I told you that we are going to meet the two types. Now, the two types of forces. Now, the two types of forces, we learned it from grade 11. Now, we have what? The contact force is what I spoke about. We've got what? The non-contact force. Those are two types of forces. What is a contact force? The contact force is the interacting object must physically touch one another in order for them to exist. So in other words, the contact force must have a contact in an object. So that we call contact. So it must have contact in an object. So it must physically touch the object. In other words, when there are two objects, they must touch one another. Now, for an example, we can take one object and another object, we attach it with a string. So the force in between is going to be what? If we stretch them, it's going to be the tension. So that tension is what? A contact force, because it has contacted the two objects. So the contact object, that is the contact force. So it must have a physical touch. That is very important. That is your clue. That is the word that you must come to your mind if you talk about the contact force. Physical touch, contact force, physical touch. That you need to know, that you need to take it into cognizance. And once come to your mind, contact forces, it means, therefore, what you need to know, you must know that they are physically touching. Now, non-contact force, it's an opposite of it. The forces work over a distance, and they without touching. So this, it's an opposite of what we said. So it's a non-contact, it's a contact. If we talk about contact, they must touch. If it's a non-contact, they shouldn't touch. So if we take an example, electrostatic force. Electrostatic force, it's a force that you create. So that are the force that you create. If I rub my hands, then I feel a heat, then what I'm doing, I'm creating electrostatic force. There will be electrostatic force in between. Now, they made an experiment when we are in lower grades, grade 7, grade 6, whereby they say, take piece of papers together, tear the piece of papers, and then take the ruler and rub it against your hair. What are you doing? You are creating electrostatic as you are rubbing the ruler against your hair, and then you start picking up the papers. There's no contact between the paper and you. You just put it there at this height, then the paper, they are lifted. So there's no that you're going to touch the papers and then they move out. So that is a non-contact force. I'm trying to explain the non-contact force and what? The contact force. I believe that you are happy to see the distinction. Now, let us go to the example as I said it. Now, if they say, give the example of a non-contact force. I said it, there are many. So I've done 3 here. I've added in our previous slide, the framework, I've only given 2. So I've added 1. I say it's a gravitational force, or you can call it a weight, electrostatic force, and I've added the magnetic force. So those are non-contact force. Now, if you talk about contact force, we therefore talk about what? Applied force, the force that you'll apply, the tension force that is in the string, the frictional force, the opposing force, and the normal force. These are the forces. And we will define each forces because we'll be dealing with this contact force plus this one. These are the only forces that we'll be dealing with. We'll be doing four forces in contact force, which is applied force, tension force, frictional force, normal force, and then we take one from the non-contact force, which is what? The gravity or the weight. So this is what we've learned in grade 11. We continue with grade 11. Grade 11, we learned the different kinds of forces. Remember, I spoke about the types of forces. Now, under the types of forces, we've got what? The kind of forces. Learners, what is very important? You must know the definitions. As I said it, definition, it's 2 marks or 0. You cannot get 1 mark. If you get it wrong, it's 0. So it's very important that every term that we are dealing with, you know how to define it. Because the examiner will want you to define a term. So you must know it. It's 2 marks. It's always 2 marks or nothing. 0. So I'm picking this so that you know how to define. Let us start with applied force. Applied force is the force exerted by an object on another object. In other words, when you have, if I am an object, right? I apply a force. Remember, we said a force is a pull or push. I apply a force in this object. If I push it, right? It means, therefore, I'm applying what? An applied force on this object. As I am an object, I'm applying a force on another object. So it's a force that is exerted on the another object. So that is very important. That is number 1. This, it's key number 1. So this is key number 1. So that applied force is very important. So in other words, you must know how to apply the normal force. Right. So I've defined the normal force for you. The applied force. So the applied force. Now let's go to the tension. All right. I've defined the applied force for you. What is an applied force? Then I said it's a force that exerted by one force to another object. So we have defined this. We know what is the definition. Let us go to another forces, the kind of forces. Normal force. What is a normal force? A normal force, it's a force acting perpendicular. This is the force that acting perpendicular to what? To the surface. So is the force is the perpendicular force exerted by the surface. A perpendicular force, this is perpendicular force, this is one. By what? The surface, this is the surface area. On an object lying on what? On the surface. This is very important. So if you draw the normal force, you start by drawing the surface, then you draw the object lying on the surface, then the normal force should be perpendicular to what? The surface. This is your normal force. So many a times learners, they draw like this and it's incorrect. They draw it like this. This is incorrect because this force does not acting perpendicular to what? To the surface. So it's high above there. For me, it's like it's lifting up the object. So, but it should be perpendicular. If we say in mathematics, we talk about perpendicular, we know that we talk about 90 degrees. So it should be 90 degrees to what? To the surface. So that is a normal force. Tension force. Tension force is the force acting on the string or on the rope. Now, tension force, this is the force that you are talking about. This is a tension force. It's acting. If you pull the rope, like this, you will feel the tension. Once you feel the tension, we say you have reached the tension force. Because if you pull it so hard, it's going to break. So now we must pull it in such a way that it has a tension. So if we've got this object, remember this object has a force that is pulling it downwards. So it makes it this one to pull it upwards. Once it pulls it upward, we call it what? The tension force. So it's a force that is acting on the string or on the rope. That is a tension force. Now we go to frictional force. Frictional force is a force that opposes the motion of an object. In other words, it's acting opposite to the applied force. Remember, I said the applied force is when you push an object or you pull an object. If you pull an object, there will be a force that is acting opposite to the force that you are pulling the object with. That we call it a friction force. So it's an opposite. It opposes the motion. Let us take an example. If there's a force that is pulling this way in this object, this force will be saying it's an applied force. So I'm pulling this object this way in this direction. So the frictional force will oppose the direction of the motion. In other words, we'll be opposing this applied force this way. So this is what a frictional force is, acting opposite to the applied force. So that is what we need to know. It's what we need to familiarize ourselves as we are defining these kinds of forces. I've said the applied force. This is an applied force. So it's exerted force on this object as I'm pulling it. You can even push it, as if you push it, you are still have an applied force this way, which is pushing the object. Now, the force of gravity. Remember, I said we are going to include the force of gravity. The force of gravity is the force of attraction exerted by the earth on an object. It's a force of attraction. It's the force that pulls the object towards the center of the earth. And what is that? It's a gravitational force, or it's a weight, or it's a gravity. All right? That is what we call. Now, the force of gravity works at the middle of the object. We cannot draw it like this. This is an object. Then we say this. It should be at the center of the object downwards. That is a gravitational force, or a force of gravity, or a weight, as we call it. So it's a force of attraction towards the earth of an object. So it attracts the object towards the center of the earth. So that is the force of gravity. So this is the force of gravity acting downwards. Now, force of gravity or a weight can be calculated. Normally, if we calculate the force of gravity, we use this, or a weight. It's going to be, we're using weight equals to mg, which is, we know that the m stand for what? The mass. And the g stand for what? Gravity. Now, this is the formula that you are given to calculate what? The weight, the gravitational force. And bear in mind that you can be given a weight problem that says an object of 50 kilogram is being pulled downwards by a force of gravity. Calculate the amount of the force of gravity on that object. They leave you at that one. What we know is that if you calculate, you must have one unknown and two knowns. Now they are giving you only the mass of an object. They said 50 kilogram. And then they say calculate the force of gravity. Now, where are you going to get the gravity? Or where are you going to get the G? we need to know that the G is a constant. Always G is equals to 9,8 meters per second squared. That is G. So we've got the value of G. So the value of G is always 9,8 meters per second squared. And you will be given that value in your constant table. So you don't have to claim it. It's there in a constant. Remember new grade 12, as you did in last year in grade 11, you are given a data sheet. So you will be still given a data sheet with formulas, with constant values. So you will be having this value. Now, if they say calculate, then the force of gravity or the weight of the object given the mass of 50 kg, then how are we going to do it? You will be saying Fg equals to mg. Then we are giving a mass of what? 50 kg multiplied by what? 9,8. Then you start calculating. You have your answer in what? In Newton. So I was just showing you that you must not get frustrated if you get the statement that you have only one figure or magnitude as a mass, but they are talking about the weight. Now, if they immediately that they talk about the weight, there's what? There's G that is pulling downwards. So is the force of what? Is a force of gravity, or it's a gravitational force? Let me put it that way. Or yeah. So I was just trying to explain what is in terms of the gravitational force and the formula there that is being used. So it is easy all the time that you can calculate the weight downwards or the gravitational force downwards, because you'll be having the two quantities, which is the mass and the G, and the value of G is 9,8 meters per second squared is what we are giving all the time. Resultant force. Resultant force. The word itself, it says result. It's from the word result. Now, resultant force or net force. The word net means grouping together. So what is the resultant force? Or what is a net force? Is the sum of two or more forces, a sum of two or more forces acting on an object. So it's a sum. So in other words, if we talk about the resultant force, or they talk about the net force, are all forces acting on an object. All. In other words, if you've got these types of forces, if you want a net force, it's going to be tension plus applied force plus weight plus minus frictional force. Why it's minus frictional force? I put it in the minus there. It's because it's acting in an opposite direction. Remember, once it acts on the opposite direction, so it opposes what? The applied force. So it should be minus. Hence, I put the minus in the bracket. So in other words, if you multiply positive and negative, you'll get a negative there. In other words, I will cancel this negative. It should be, then if I multiply positive, this positive and negative, this negative will go out. Then in a bracket, it will be tension plus applied force plus weight minus frictional force. That is the formula for the net. So is the sum. Sum is the addition. The word sum means addition of all the forces that are acting in an object. So if we talk about the resultant force, what comes to your mind? It comes the sum of two or more forces. So in other words, it's an addition of all the forces. Two or more forces acting on an object that we call a resultant or a net force. I hope we just recapping in what we have learned last year, what we have missed even last year. Maybe it's trying to help us now. We are trying to figure it out. We are trying to see as to what is happening. Remember, learners, we are on live And we have our WhatsApp number that you can use, which is 079 578 2908. You can just WhatsApp so that we can, where you have a challenge, we can fix, or we can just WhatsApp you back and then tell you how to attack that challenge. So we are live. Types of frictional forces. We still learned this one in grade 11. You know, I love grade 11 because it's unpacking things. It's making things very easier for grade 12. So now, types of frictional force. I'm not talking about the forces. I'm talking about specifically frictional forces. If they say the types of forces, we spoke about the contact and the non-contact. But now here we're talking about the types of frictional forces. What is frictional force? It's a force that opposes the motion of applied force, right? We've defined that. Now, there are two types of frictional force. We've got static frictional force. We've got kinetic frictional force. Static, it's limiting. Kinetic is dynamic. Now, what I want us to get into our mind, learners, is that if I say static, I'm talking about something that is stationary, something that is not moving. That is static. As you are seated there watching, you are static. You are watching me, you are not moving. Then in other words, we have what? Static force. But if you start moving from one position to another position, then you start applying what? A kinetic force. Now it becomes what? Kinetic. So it is very important that you know what we mean about static, what we mean about kinetic. So immediately what comes to your mind when we say static, this word must come to your mind. Stationary. This word must come to your mind, stationary. Now, if we say kinetic, this word movement or moving must come to your mind. That is very important. Now, what is kinetic? What is static? Sorry, what is static frictional force? Because remember, here to get marks, you must know definitions. You'll get a lot of definitions. I'm telling you, if you want to pass, you must know the definitions. You'll pass the paper. You'll get a lot of definitions in the paper. Each topic starts with a definition. So you must know the definition. Just grapple with this. Get this definition into your skull. Then you'll pass the paper. Now, static or limiting frictional force is what? It's force that is acting between the two surfaces of an object. That is what? Stationary. Now, if you have an object that is sitting on this surface, there are forces that are acting on this object and make this object stationary. We may have this force. We said it's what? The force of gravity. We may have this force, which is normal force. These forces are keeping this object what? Stationary. This object is stationary. So we may have this force acting that way, which is what force? It's applied force. If I pull it, and then there's a force that are acting against the applied force. We said what? It's a frictional force. So all these forces are keeping this object stationary. So this object, as it's stationary, it contains what? A static frictional force. It's very important. Now, we have the formula that we'll use to calculate the static. And this formula, you don't have to cram it. You'll get it in the data sheet, but you should know how to apply. The challenge is to how, we are testing the skill here, the skill of how to apply, how to do it. So the how part of it is very important. So once you have the formula, it comes to mind to how I'm going to apply. So this is the formula for static frictional force, which is F. F stands for force, S stands for static. So this is a static force equals to the coefficient of static. This symbol, we call it mu, or we call it coefficient. So it's a coefficient of static. Then multiply by what? Multiply by the normal force. And you see the N there. The N says normal force, which is that one, the normal force. So the formula, it's a static force, it's a coefficient, and it's what? The normal force. And as you calculate, remember when we calculate, if you calculate a force, we are going to use the formula what? Net force is equal to MA, which is mass times acceleration. What is the SI unit there? It's a force. Remember we said when you calculate the force, you must have an SI unit, which is what? Newton. But here, if you calculate, you don't have to put an SI unit. And don't be afraid, you won't be penalized. Remember, if you leave out a formula, you'll be penalized for a mark for not, the SI unit, you'll be penalized a mark for not putting in the SI unit. So, but here, even if you don't put the SI unit, there's no SI unit for the static. I hope you understand this. Let us go to kinetic. Kinetic is what? Movement. We talk about movement when you talk about kinetic. Now, here we've got what? The movement, the moving of an object. Once you start moving, you become dynamic, changing. So we are moving. So even here, we say it's a force that acts between the two surfaces when the two surfaces when the object is moving. So pardon me with the when the object is moving. So here is stationary, here it's moving. Now we've got the formula to calculate the kinetic. Remember, we had a formula for what? The static. We have a formula for kinetic. It's the same formula. What differs is we denote it or we differentiate it with the S and the K, but it's still the same. The S is for static, the K is for what? The kinetic. So we still have the force of kinetic or the kinetic force. We have the mu, which we call it what? The coefficient, and we have what? The multiplied by the normal force, which is the force. Even that one is one the same, and it follows the same. We've got the kinetic force, frictional force, we've got the coefficient, we've got the normal force. We don't include the SI unit when we calculate because we don't have SI unit. So this is going to help you when we come to the calculations of Newton's second law. Remember, I want you to put that one in your mind. When we come to Newton's second law, we are going to use this. We are going to need especially this formula. There's somewhere we are going to be asked to calculate the kinetic force or the kinetic friction and the static friction. So you must know this. So this work, it has helped us a lot. So to understand what is all about the force. Remember, Newton's law is about forces. Because we are going to talk about Newton's law now, we're going to talk about forces. What are they doing? All right. I believe and I understand that you have understood what I've revised with you from grade 10 to grade 11. Let us now embark on our lesson for grade 12. Okay. Force and free body diagram. Now, you will be required to draw the free body diagram. You'll be required to do a force diagram. Now, what you do if you do a force diagram or a free body diagram? Remember, I told you in the beginning in our structure there that the force diagram or a free body diagram, these diagrams are used to represent forces acting on an object. The tips, how to draw them. 1, determine whether the object is moving, vertical or horizontal, or not moving, stationary, if not moving. Now, it's what we spoke about in the previous slide, that to say, if the object is stationary at a rough surface, then we've got what? Static force. If the object is moving in a rough surface, then we've got what? The frictional force. So this is what is very important. So if the object is on a smooth or frictionless surface, there is no what? There is no friction. Because it's frictionless surface, there will be no friction. Once there is a rough surface, then is then that you will have the static and the kinetic. Then determine the number of forces acting on the object based on the given scenario. So this is very important. The number of forces will be determined when you have the scenario. Then the marks are allocated. You look at the marks, how many marks are allocated, they will tell you how many forces that you need to draw. And then if a question is allocated 4 marks, there are 4 forces, is what we are saying. So the number of marks will determine what? The number of forces. So it's very important if we are going to draw the forces. Now we are going to move fast. Now, free body diagram and the force diagram. The force diagram, we use a box. If you draw the force diagram, then you draw all the forces. But if you draw a free body diagram, you only use a dot, then you draw the forces, the number of forces. Let us take this example. An object is pulled by a constant force on a horizontal rough surface to the right. Now, this is an object pulled by the force in a right direction and then is in a rough surface. Now, draw and label the free body diagram indicating all the forces acting on an object. They want us to draw the free body diagram. And they want us to draw, you can draw even the force diagram. Now, this is how you draw it. This is a force diagram. You've got this force pulling this object that way, as we are shown, and then we've got what? The normal force acting perpendicular to the surface, the gravitational force acting from the center downwards, and the frictional force, which is acting opposite to the applied force. Now, remember, if you draw the free body diagram, the force diagram, you must draw the object. You must show the object. So this is an object. You must show the object. So if we go back, this is the object. So if you draw the force diagram, you show the object. So you show the object. But if you draw the free body diagram, you don't show the object. You only the object, you denote it by what? A dot. So then you draw all the forces that are acting. The same forces, you draw them like that, then you name them. Now, given a scenario when an object is hanging. Now, how many forces are there if we think? Yes, the object is hanging on the ceiling. Here it is. How many forces we think they are acting there? 2 forces, right? So this is going to be this force and that force. Let us see that we are correct. This is the force, is a force diagram. We've got the tension force and we've got the gravitational force. This is the free body diagram. We've got the dots. Remember, I said the free body diagram, it denotes with the dots, a dot and the tension force up and the tension force downwards. Let us see this one. We've got forces, we've got a man pulling a rock, right, at an angle. They want us to draw the free body diagram and the force diagram. What do you think is, how many forces we should try here? We think of this force, this is a pulling. We think of that force downward. We think of that force opposing that one. We think of that force going upward. 4 forces, isn't it so? Because they are acting at an angle. Let us check. Voila, these are the forces, exactly as we've mentioned there. So we've got that force pulling that way, that force downwards, that way, upwards, that way, opposing. So we've got those 4 forces. Even in the free body diagram. So in a free body diagram, we said we denote it by a dot. So this is how we draw the forces. Now we go to straight grade 12. Now, objectives of these lessons of Newton's law. You must know, at the end of this one, you must know how to state, this is very important, to state the three laws. These three laws, you must know how to state it. I said it's true or nothing. Then you apply it in a real life. Apply it in a real life, or predict and explain different phenomena using the laws. That is what is going to happen. Now, to understand Newton laws, there are three laws, as I put it. Newton's first law. This new law is applied in a single object. Now, what does it state? It says an object continues in a state of rest, number one, state of rest, that is number one, or moving in a constant velocity, which is number two. So this is very important. As you are going to define the law, as you are going to define or state the law, we will have what? The object is moving in a constant velocity, or the object remained what? Stationary. And this, we know that if it is, it means therefore F is equals to, if it's moving or stationary, then your F is equals to 0. Now, if we talk about Newton's second law, same, it's applied in a single force. So it's a single object. But now this is a relationship between the two. Relationship between the acceleration and the force, and acceleration and the mass. So now it says it's a non-zero. It means therefore once it's a non-zero, it means there is a force that has been applied. There is going to be an acceleration. So acceleration here is going to be 0. And the force here is going to be 0. But here, there is a force applied, and there is acceleration that is going to happen if you apply a force. So it says, net force of an object acting on an object will cause the object to accelerate. It moves. If you apply an object, then it accelerates. But this acceleration is directly proportional to what? To the force, and inversely proportional to what? To the mass. What do? It says F proportional to A is inversely proportional to M. Is what they are saying. When you apply a force, the object will move, will accelerate. That is directly proportional. When acceleration, then you apply a force in a bigger object, and then the object does not move, then that acceleration is inversely proportional. Inversely, it's 1 over m. 1 over m. This sign is called proportionality sign. So A is inversely proportional to the mass, because it's if the mass is bigger. Now, the first number 3, the law number 3, this is between two objects. You have object exerting a pressure on another object, and that other object is going to exert the same pressure, or same force on that object, but in an opposite direction. Not pressure, learners, but forces. It exerts a force in the other object, and this other object is exert the same forces in an opposite direction. So remember, I said we call this action-reaction pair, but we can't define it, or we can't state it as action-reaction pair, but we define it as when object A exerts a force on object B simultaneously exert an opposite exert an opposingly directed force on an equal magnitude. So in other words, if A exerts a force on B, B will exert the same force in an opposite direction, but in an equal magnitude. That we need to understand. Now, let us state Newton's first law. Newton's first law state that an object continues in a state of motion or of rest. Remember, we say state of rest, say stationary, or in a uniform acceleration. When we go back, we said in that slide, we've got the stationary and we've got what? The uniform. So we talk about this one. So if you define this law, you must define it as the object continue in a straight line. You suppose here we have straight line, or the object continue in the state of rest or uniform velocity unless is acted upon by this force, unbalanced force, or net resultant force. Net or resultant force. So this is how you define the law, and this law is 2 marks. Now, the Newton's first law, as I said it, is also known as a what? Inertia force or inertia law. Now, what is inertia? This is very important. You will be required to define. It's a property of the body to resist any change in a state of motion or rest. Now, if you sit on the taxi or on the bus, when the bus driver apply the brakes, what happened to you? Suddenly, you are going to move forward instead of sitting. What makes you to move forward is what? The inertia. Inertia pulls you. It resists you to stay, but it pulls you forward. That is what an inertia. That's why they want us to fasten what? The seat belt, so that we cannot be thrown out of the bus. So that is an inertia. So inertia depends on what? The mass of an object. How bigger is the mass, or how smaller is the mass? So the bigger is the mass, the bigger is what? The inertia. So the inertia depends on the mass of. That is very important as well. You must know. So what is the mass? A mass is the quantity of an object that is possessed. If I'm weighing 50 kilogram, 50 kg, that is the mass. You know, people they say, that is not a weight. A weight is the force that is pulling. There's a difference between a weight and a mass. Kilogram, it's talking about what? The mass, right? So it's a mass. A mass is a measure of inertia of the body. The quantity of the matter, that is a mass. And it's measured in what? In kg. So we've got the kg. If I have a bathroom scale, I stand in a bathroom, if I've got 50, then it means my mass is 50 kg, not 50 Newton. That is incorrect. We're using the language incorrect. Now, how to use the Newton first law? Now, wearing the seatbelt, as I've stated, wearing a seatbelt is very important. It prevents us not to go through while the brakes of the car are being applied. It's very important. That's why we wear the seatbelt. So this is application of Newton's first law. Because wearing the seatbelt, without wearing a seatbelt, if the car is traveling at 120, you are traveling with the speed of the car, 120. Once we apply the brake, you'll fall out at the window or through the window at what? 120. Then you die. So hence they say let us fasten the seatbelt. That is the use of the seatbelt. Now, how does the seatbelt assist reduce the serious injuries? When the car collides, it comes to a sudden stop. The person inside the car will continue moving forward with the inertia, is what I've explained. So now the seatbelt, it helps us to sustain what? The inertia. Without the seatbelt, the person will make contact with the windscreen. That is, will cause what? Injury. Now, the safety belt counteract the inertia. That is very important. It counteracts what? The inertia. It prevents the moving forward of the person. So this is very important, wearing of the seatbelt. Now, inertia is determined by what? The mass of an object. The greater the object mass, the greater is what? The inertia. That is very important. Now, Newton's second law. I'm pushing these laws so that you know them. There's nothing that you can do with Newton's first law. What you need to know is how to explain it, how it's been done practically in real life. So in real life, we said in terms of what? Seat belt. So that is very important. That it counteracts what? The force that is pulling you, the inertia that is pulling you forward to prevent injury. So that is Newton's first law. Newton's second law. This is the law where you'll be required, and if you look at the question papers, this is the law that has been tested many a times, because that is where we are going to do calculations. Now, Newton's second law states that when a resultant force, remember a resultant force or a net force is a sum of the forces acting on an object, is applied on a mass of an object of a mass. It accelerates an object in a direction of what? Of the net force. The acceleration is directly proportional to the resultant force or the net force and inversely proportional to the mass of an object. This is what you need to know. 2 marks or nothing. And I said it. If you want to remember this law, do it mathematical and say F proportional to A, or A proportional to F, and A inversely proportional to M. This is what the law says. Acceleration is directly proportional to the force or net force. Acceleration is inversely proportional to the mass. So this is what the law says. If you want to understand it, or go to your data sheet, you find this formula. Then you unpack it like this. You've got the net force, which is this force, is directly proportional to acceleration. And acceleration is inversely proportional to what? To the mass, is what we are saying here. So you don't have to claim it. You must know where you get this law, or where you the formula will assist you to state the law. Now, this law, it gives us the formula that we're going to calculate, which is what? F net equals to MA. What is F net? Total forces that are acting on an object equals to the mass multiplied by acceleration. What is acceleration? You dealt that one in grade 10, grade 11. It's a rate at which is a rate of change of velocity. That is acceleration. When the car starting moving, it moves, change gears, and then it moves. It has a constant acceleration. It doesn't change. Then that's why we're saying the car is accelerating. It's moving. It's accelerating. So it's a change of what? Of the velocity. Now we calculate acceleration with this formula, which is acceleration is a delta V. Delta means change. Then V delta T, which change of time, which is the rate. Rate means change of time or time. Now, acceleration is measured in what? Meters per second squared. Now, solving strategy. Because here we are going to solve the problem. Here you are required to calculate. Now, in Newton's law, the following are important, especially Newton's second law. But basically, if we want to know the 3 laws, read the scenario carefully before attempting to respond. Identify whether the scenario is in or it involves Newton's first law, Newton's second law, Newton's third law. The key words such as rest, stationary, equilibrium. These 3 words, they mean one and the same thing. It means the object is not moving. Or once it's accelerates, then there's acceleration, there's an applied. Now, once you talk about rest, stationary, equilibrium, you must know that the net force is equals to 0. Now, if it accelerates, we talk about what? The non-zero force, which is the force is not equals to 0. The force is applied is the one that makes the object to accelerate. So its speed or its slow down. So these are very important. These ways are very important. They are guiding you as to you understand when we talk about the stationary, the rest, the equilibrium, and accelerating. Especially when we go to acceleration, then this will be what? Newton's second law. Newton's laws, following important. Now, they will want you to do what? To draw the free body diagrams or the force diagram. It's very important. And you must understand that this object is acting on the rough surface or a smooth surface. Read the question. Before you attempt, you must read. If it's a rough surface, you must think of what? The static force and the kinetic force. Then you must know how to pick a correct formula in your data sheet, the substitution, and the answer. These contain 3 marks or 4 marks with an SI unit. Pay attention to what? A vector. We said vectors, they must have both magnitude and must have what? The direction. You must pay attention to that because it's very important. Multiple steps is 4 or more. If you do the multiple steps, one, then you finish the other one, then you take the answer to the other one. That's scaffolding. So it's very important as well. So it's 4 marks or more. But the other one, this one, is only 3 marks because it's a formula substitution and what? The answer. Tips on the answering questions. Analyze and give statement and look for keywords. Keywords are very important, such as constant velocity. What does that mean? It tells you that if we talk about constant velocity, then acceleration is equals to 0. And the net force is equals to 0. Once you see the weight constant, the two are equals to 0. Determine the direction of motion or displacement of an object. Draw a free body diagram or a force diagram. It's very important. Then applying Newton's second law on each object and add the forces. Now we are going to deal with this as we are doing the calculation. It's just a strategy. Now here's an example, a work example. Remember, we are in Newton's second law and we are going to use calculations. Now, on the way to work, an electrician put a toolbox of mass 2 kg on a back seat of a car. A co-worker in the passenger seat noticed that children were crossing the road and shouted that the electrician should apply the brake or stop the car. The electrician applied the brakes suddenly and the car stops. Now, during the braking period, the passenger's body of mass, these were given a mass of the passenger's body, move to the edge of the seat. Move to the edge of the seat. Then we go to what? What you spoke about? That what makes the passenger body move? It's an inertia, isn't it so? It's an inertia, right? Then we must recall. And the toolbox fell to the seat back. So all these ones, the state of inertia pulls them. Now the question says, this is 3 marks. Name and state the law of motion that could be used to explain the situation above. Now, what law explains the situation above of the movement of the passenger's body or the toolbox? Name the law. We know that it's going to be Newton's first law or the law of inertia. And then we're going to state the law. Then number 2, 1.1.2, it says, which one, the passenger's body or the toolbox, has more inertia? Explain the answer. That is very interesting. Let us explain the number 1. Number 1, we said, is Newton's first law, which states that an object will remain at rest or continue moving at a constant velocity or a constant speed along the straight line unless acted upon the non-zero force or the external resultant force. That is, this is not 3 marks. I've just putting it as 3 marks for just, the 3 marks will come as the 1 mark for the naming of the law, but stating of the law is 2 marks. So all of this is 3 marks. So the naming, it's 1 mark. Then the stating is 2 marks. So we've got 1 and 2, which is 3 marks. All right. Now, they said which one? Now it's a passenger's body. Why? The mass of the passenger's body is greater. Remember, we said the greater the mass, the greater is what? The inertia. So the toolbox, it has a lesser mass. So the greater the mass, the greater is the inertia that will pull the passenger towards the windscreen, or towards or forward. So that is it. Or the inertia is determined by the object mass greater than an object mass. The object mass, the greater an object mass, the greater is the inertia. This is very important. These two explanations are very, so it's either you take this one or you take that one, if it's 2 marks. So this is how we answered these questions. There's another example. This may seem difficult because of a drawing, and it may seem puzzling because of a drawing, but we need to read the statement. 2 blocks of mass 4 kg and 7 kg are connected by a light intensible string. This is a string. A force of 25 Newton is applied. Now is applied, what do we think? It's an applied force, right? It's applied at an angle of 30 degrees. This is what is being shown here. To the horizontal on the block of 7 kg. As shown the diagram below. The system moves to the east, so it moves in an easterly direction. Each block experiences a frictional force. Now we're given a frictional force of what? 4,5 Newton. So this is what we are given. Now, many times they give us the weight and the drawing. If they give you only the weight, you must do what? The drawing. Do the drawing, right? Now, state Newton second law of motion is 2 marks. Always will be 2 marks. Say state, right? Draw the free body diagram of all the forces indicating on this block 7 kg. Now, we said if you look at the body diagram, what can tell you how many forces that are there are acting? What is that can show you how many forces are acting there? How many forces that you should draw? Remember, marks. The marks will show you how many forces that you should draw. So we've got 5 marks. It tells you how many forces we should draw. 5 forces, because it's 5 marks. All right. Then 1.2.3, it wants us to calculate the acceleration of the system, and then 1.2.4, the tension. Now, we're going to be quick. Newton's second law, we know what is Newton's second law. Newton's second law, it says an applied force or a net force applied to an object of a mass is accelerated. It accelerates in the direction of the net force. This acceleration is directly proportional to the force and inversely proportional to the mass of an object. That is 2 marks. Now they say draw a free body diagram. Remember, they wanted us to draw the free body diagram and of the block 7 kg. And the 7 kg is, when we saw the marks, was 5 marks, right? Now, if it's 5 marks, we've got the one that is acting at an angle. We've got the one that is acting downward. We've got one that is acting there. We've got one that is acting there. Where's the other one? We've got this. Remember, it says a frictional force, a tensional force. This is 5. So I wanted you to come guessing. So this is 5. This is the one that is acting at an angle there of 25, if I'm not mistaken. Then this is FG, this is FN, this is FT, this is F. These are 5. This is 5 marks. Let us see that we are correct. Voila, we are correct. These are 5. Right. That is how you are doing it. That is how you are placing it. That you've got the 5 marks. This is the 5. Right. Now, we've drawn the free body diagram. And the free body diagram, remember, it says you need to have what? The dots. Dots. Nothing else, the dot. So we place the dot, then we have the forces. All right. Now, solution, calculation. They needed us to calculate. This is 6 marks. The first step that you need to do, draw all the free body diagram. That's first. This is the free body diagram of 4 kg. This is a free body diagram of 7 kg, if I'm not mistaken. Right. Now, why I'm drawing all the free body diagram? They will help you in terms of what? Getting the net force. All the forces acting on an object. Let us move faster now. We've got these two, this is block, let's say it's block number 1, which is 4 kg. It has only have 2 forces acting on it, which is the frictional force and the tension force. Now, we start each block. Start with one block and then we'll go to another block. Now, this block is this block. That it has this one and that one. This is T, this is f of x. Now, this is the block that this we call it what? A force diagram, but it is very important to draw a free body diagram because it's going to show you. Right. Now, first thing first, we start by the formula, this formula. Net force is equals to MA. That is very important. Now, what is net force? All forces acting on an object. So, we have got this one and that one. So, it's a sum. Remember the sum of the forces. So, the sum of the forces is this one, T, minus, which is said minus because it's acting in an opposite direction. So, this represents this one, the net force, equals to MA. That is very important. Now, you then substitute. You don't know the value of T, but you know the value of the frictional force. Remember, we are given there, the frictional force is what? It's 4,5 equals to, you know, the force, I mean the mass. The mass that you are given is what? 4 kg. This is 4 kg multiplied by A. We don't know A. Now, you take the numbers together, you leave the unknown. Now we've got T, which is this side. We take this one on the other side of the equal sign, which is minus, is going to be positive. It's going to be A4 plus this minus, it becomes positive when you transpose it to another side. It becomes positive. Then you leave it as equation number 1. You leave it at that. You can't solve it anymore. You go to block B. Block B, how many forces are acting there? You've got 1, 2, 3 forces. Remember, we did the force diagram. Then, if we have the total forces, we said the net. So the net, how many forces? We've got T, which is this one, plus minus f, which is this one, which is minus. Why you say minus? Because it's an opposite. We don't say this is minus. This one is acting opposite. That's why you put a minus in a bracket, which are two forces. Then plus, right? Plus mass times acceleration. Now you've got another force that is there, which is a what? Applied force. Now, in other words, you must put all of them. Now, if it's all of them, then you are saying f of s equals times cos, which is this one, then plus this t plus this one plus this one. Then they give you what? They give you a second equation. Now we've got two equations, this one and that one. Combine the equation. Now, all the time, substitute this equation in that equation. All the time. Substitute equation 1 to equation 2, which is, you've got 25, which is the force applied, multiplied by what? The cos theta. Cos theta is 0,866 minus the substitution. This is the substitution of this one. Equals to this one. Then you take the calculator. When you calculate, you come up with this answer. So it's very easy. You take this, you substitute to this one. You calculate this first, which will give you this. Remember, this you are giving the value, which is this one. This one will be that one. Then you substitute this, this, which is this one, there. Then you have this. Then you calculate, right? Then tension. Tension is simple. You can take one of the equation 1 or equation 2, but it's correct. It's easy if you take equation 1. This was equation 1. Then you substitute. We have calculated already your acceleration. You know what is the acceleration. So you have 4. We have calculated this one as acceleration in the previous. Then you add this one, you get your answer. It's very simple to calculate. This is going to be your 2 marks or 1 mark. So it's very simple. Even if you can use the equation 2, you'll find the same answers. Right. This is your work example activity that I want you to do. You'll follow what we have done. Now you'll read the statement. Then you'll draw this, draw the free body diagram. They want you to state the free body diagram. How many marks? Now, of what? Of P, this P. How many you get your formula there? I mean, your forces, it means there should be 5 because it's 5 marks. Then you state the newtons, which is 2 marks. Then you calculate, this always 6 marks if you calculate there. Then you calculate as we've done the previously. It's going to be the same procedure, same. This is what I want you to do with your teacher. I want you to be so creative. You'll read the statement there, then say, what do you think will be the first question for this and how many marks? The first question will be drawing of the free body diagram, right? Either of the two. Most of the time will be the B1, drawing of the free body diagram and how many marks. Then you will determine how many marks, then you put marks. What will be the second question? The second question can be state Newton's second law, which is 2 marks all the time. What will be the third question? The third question can be calculation, which is 6 marks. Then the fourth question will be calculate the tension. This is acceleration. This is the tension. This is 2 marks. This is 6 marks. Then you start solving. Then you can do this. I want you to be as creative as possible. And with your teachers, give yourself marks and then start solving your questions there and your marks. All right. This is what definition of acceleration. We said it is a rate of change of velocity, and calculate the acceleration using this. All right. It's these activities. You just follow what I've done follow what I have done. All right. The last one, Newton's second law, because we're pressed with time now. Now, Newton's third law. Newton's third law, there's no calculations. You must know the law. The law says it states that the body A exerts a force on body B, and body B simultaneously exerts an opposite force, a directed force of equal magnitude on body A. This, if you want to understand it easy, use this block. Body A, FA exerts a force on B. B exerts a force on A in an opposite direction because of this minus opposite direction. So this is what you need to know. This law is only what you need to know to state the law. That is only you need to know, right? In Newton's second, there's no calculation. The law that requires calculation is second law. That one requires calculation as we did it, as I've shown you how to do it. And it's very simple, learners. It's very simple. It requires how to do simultaneous equation. To sum up, this is our last. Remember, I started with the summary. I end with the summary. So if you have these two summary, they summarize everything that we have spoken about. I said when we started, we've got three laws: Newton's first law, Newton's second law, Newton's third law. How do you define or state Newton's first law? This is the definition of Newton's second law, which tells you this is a definition of or state of Newton's second law. This is the state of Newton's third law. So everything is in there. Is what we said it. Then Newton's first law, an object moves in a constant, remember I said in a constant velocity, and object can be at stationary. This is what we said it, as I said, the understanding of law. I've told about you this one. Then this one, it's a proportionality. Now it tells you that acceleration is directly proportional to the net force. Acceleration is inversely proportional to what? The mass. So this is going to give you the law itself. You don't have to claim it. You can take it from there and then you put it together. Now, this one, the bodies, two bodies involves. The one exert a force on the other one, and the other one exert the opposite force on the other one. The A exert a force on B, B exert a negative force, the opposite force on A, but in what? Equal magnitude. That you need to, is all that you need to know. And then, lastly, this law, first law, it has what? Inertia. It's a law of inertia. Inertia is what? It's a tendency or a property of body to resist change or to keep the body at rest. That is inertia, is what we spoke about. And this one are properties of Newton's third law. It has equal magnitude, opposing direction, force acting on the same line, force not cancelling each other. That is what we need to know. And learners, I think we have learned a lot. Learners, I think we have summed up everything. We come to an end of our lesson. Thank you so much for listening. Thank you so much for being with me. I hope you have understood. Thank you for watching this lesson. Please remember to sanitize, wear your mask, maintain a social distance, keep safe. I thank you so much. Tech Science moves.